Ep.1The.
Hello, this is Rainbow Blueberry. I will start narrating a space documentary to help you sleep well. Today, we are going to talk about the beginning of the universe, its origin. This story will explore how this vast universe we live in was born and the journey it has taken to reach its current form. Please sit back or lie down comfortably and join us on this journey while imagining the mysteries of the universe in your mind. The universe began about 13.8 billion years ago from a single point. This small point, infinitely small and dense, was the starting point of everything we know. Scientists call this moment the Big Bang. The Big Bang was not just a single explosion. It was the moment when time, space, and all the physical laws we know were born. The Big Bang started in a state of unimaginable heat and density. All the energy was condensed in this state, and as this energy suddenly expanded, the universe was born. At this moment, time and space began, and we can call this point the 0 second of the universe. In the first moment after the Big Bang, nothing existed, no matter, no light, not even space. However, after the Big Bang, the universe began to expand very rapidly. This expansion was the force that created everything, and through this force, the first particles were formed. At 10 to the negative 43rd seconds after the Big Bang, the universe was still unimaginably hot and dense. We call this period the Planck era, and during this time, the universe was like a vast sea of energy. After the Planck era, the universe began to expand and cool rapidly. At 10 to the negative 12 seconds after the Big Bang, the universe was now filled with quarks and gluons. Quarks are the fundamental particles of all the matter we know today. These quarks combine to form protons and neutrons, which then gather to form atomic nuclei. The universe at this time was very chaotic and intense. Quarks and antiquarks, along with various particles, were constantly being created and annihilated. But even in this chaos, order gradually began to emerge. Protons and neutrons combined to form atomic nuclei, and electrons began to orbit around them, forming the first atoms. These atoms were primarily composed of hydrogen and helium, which today make up over 99% of the universe's matter. The elements formed during this time became the important materials for forming stars and galaxies later on. After the Big Bang, the universe continued to expand and gradually cool. As the universe expanded, the temperature dropped, and matter began to condense into larger structures. During this process, light elements like hydrogen and helium were formed, which laid the foundation for the universe's evolution. About 380,000 years after the Big Bang, the universe cooled enough for electrons and protons to combine and form neutral atoms. This moment is called the recombination era, and at this point, light was first able to travel freely through space. This light is what we call the cosmic microwave background radiation. The cosmic microwave background radiation still fills the entire universe today and is used as strong evidence that the Big Bang actually happened. This light allows us to glimpse the early state of the universe, and through it, we can explore the origin of the universe. After the first light was released, the universe continued to expand and cool. During this time, matter began to form larger and larger structures. As gravity pulled matter together, gas clouds began to condense in denser regions, and in these regions, the first stars were born. These early stars were very large and bright, and their lifetimes were very short. They were primarily composed of hydrogen and helium and released tremendous energy through nuclear fusion. However, these giant stars did not last long and ended their lives in supernova explosions. Supernova explosions spread surrounding gas, providing material for new stars to form. As this process repeated, galaxies gradually formed, and the vast structures of the universe we see today were created. Galaxies contain billions of stars, and each star has several planets orbiting it. These vast structures are held together by gravity, and within them, the universe is constantly changing. Galaxies are one of the important structures in the universe. In the early universe, small gas clouds gathered together due to gravity, forming the seeds of galaxies. Over time, these small clouds merged to form larger structures, eventually leading to the birth of galaxies. At the center of many galaxies, there is often a supermassive black hole. These black holes have immense gravity and pull in surrounding gas, emitting bright jets and powerful radiation. During this process, stars form around the black hole, playing an important role in the evolution of the galaxy. Galaxies have evolved by interacting with each other. When two or more galaxies collide, the stars within them form new orbits, and gas and dust condense again, leading to the birth of new stars. These collisions change the structure of galaxies, leading them to evolve into increasingly complex and enormous forms. Our Milky Way galaxy was formed through such processes. The Milky Way has a spiral structure, and at its center lies a supermassive black hole. Around this black hole, countless stars gather, and along the spiral arms of the Milky Way, many stars and nebulae are located. In the early 20th century, Edwin Hubble first discovered the expansion of the universe. He observed that distant galaxies were moving away from us, leading to the conclusion that the universe was expanding. This discovery laid the foundation for modern cosmology and played a crucial role in understanding the origin of the universe. The expansion of the universe doesn't just mean that galaxies are moving away from each other. The entire universe is expanding, with space itself stretching. This expansion continues today and is accelerating over time. Scientists explain this acceleration with dark energy. Dark energy is spread throughout the universe and plays a significant role in accelerating the universe's expansion. However, dark energy remains a mystery, and scientists continue to research its true nature. The expansion of the universe is a key factor in determining its future. If the universe continues to expand, all galaxies will eventually drift so far apart that the universe will be left in darkness. This scenario is known as the heat death, where the universe keeps expanding endlessly, all energy is exhausted, no more stars are born, and everything ends in a cold death. Another possibility is that the expansion of the universe will eventually stop and begin to contract. This scenario is known as the Big Crunch. According to this theory, the universe will eventually collapse back into a single point, potentially leading to another Big Bang. This is one of the theories that supports the idea of a cyclic universe. As we explore the origin and evolution of the universe, we are reminded of how vast and mysterious the universe is. The universe, which began with the Big Bang, is constantly changing, with new stars and galaxies being born within it. And within this immense universe, we exist as small but integral parts. Despite its enormity, the universe gives us a deep sense of connection. We are part of the universe, living within it. Exploring the universe is not just about expanding scientific knowledge, but also about understanding who we are and where we came from. The endless possibilities and mysteries of the universe provide us with a constant opportunity for exploration. As we strive to unlock the secrets of this vast cosmos, we also find ourselves asking more questions. But within these questions, we discover our place and role, finding true peace. Now, as we conclude this journey of exploring the origin of the universe, I invite you to close your eyes and drift into a peaceful sleep, immersed in the deep darkness of the cosmos. The journey that began with the birth of the universe will continue in your dreams. Good night. This has been Rainbow Blueberry.